Hello team, today's challenge is itinerary arrangements where we're given some optional destinations or what do they call them here? Stops, right? They call them stops. And we need to be able to see how many different ways we can slot those in between our fixed time slots, which are breakfast, lunch, and dinner, right? So these destinations, these itinerary items stay fixed. We're allowed to slot as many as we want, but at least one between breakfast and lunch, as many as we want, but at least one between lunch and dinner, and then we can do an optional one after dinner. Okay. So with this, because it involves combinations and permutations, we're probably leaning into factorials. In this case, we absolutely are. So we're going to jump over to some code that I did in the past, this factorializer, and borrow from it. Okay, if you remember that challenge, we ended up pretty much with this function. I did change the error message, right? But first, making sure that we weren't in the negatives, right? That's important. If we are, we should throw an error because factorials don't really like negatives. And then if it is 0, return 1 because we are doing recursion here, okay? So 0 mathematically equals 1. We do that, and we multiply the whole thing together. So if we had, say, an n equal to 5, it would be 1 times 2 times 3 times 4 times 5, right? That's the whole thing about the factorial. Well, with that, we can copy this over and bring it in just like this, okay? And then down here, we absolutely use that. So we can just go and grab this part and replace stops. And then where does the n come from? Well, it comes from stops, right? N equals stops dot length. And it's curious to me that we don't actually care what's in stops. We only care what the length is. That's the only time that we use stops. But we get that, okay? From here, we know what the combinations are, okay? We can figure that out. And if all we had to do was do that part, then great. We can absolutely do that, right? What we can't do is figure out how to slot these together. And for that, we need a little bit more. What we end up doing is multiplying by something, okay? And for that, a whole lot of Google searching brought me to this, okay? Where we distribute n stops into the slots. The slots are pre-lunch, that's between breakfast and lunch. Pre-dinner, that's lunch to dinner. And then post-dinner. And if we didn't really care about anything about these, if it was just one or more, then it gets really clean. But because that post dinner, because that C requires us to be 0 or 1, the math changes. Okay, and this actually ends up being our control. So if we go down, we figure it all out, and we find that if C is 0, it's weird that it's not capitalized. Sorry for that. But if C is 0, then the math is n minus 1. If C is 1, then the math is n minus 2. And in fact, we end up using that right here. So n minus 1 plus n minus 2, and it's done. Now, if you read a little bit further, we can actually join these up, right? So we can go n minus 1 plus n minus 2. That ends up being 2 n's, right? There's 2 n's in there. So 2 times n minus 3, right? Because minus 1 plus minus 2 is, well, it's minus 3. So we can actually change this, bringing this down, getting rid of this one, changing it, and going 2 times n plus, minus 3, right? And it should still work. Now, if I just did this today, if I just left it here, would I remember this in 6 months? Absolutely not. This totally looks like magic numbers, even though there's a whole derived formula for how we got there. So because I am unlikely to remember how I got to this part, I would probably leave the comment in today, right? I don't usually do a lot of long comments, but again, 6 months from now, I want to be able to remember that, oh, there was some stuff here. So I might not save this because commented code sucks, and we don't want to leave that in there. That's what Git is for. Instead, I would leave the comment that got me to this formula, right? Especially this last part where I explain that the two parts do separate things. The factorial counts how many ways we can change the order of that array, right? How many different combinations we can get there. And then the 2n minus 3 counts how many ways we can split that up, how many ways we can slice it so that it appears between, between breakfast and lunch, and then between lunch and dinner, and then that single one after dinner, right? So I'm probably not going to remember this in the future, but the comment is there to help me. And that's where I would leave it today. So this is one of those ones where I would actually leave those comments in. And that's okay sometimes, right? Not commented code, but the comments that lead to the thinking around this code, right? Very important stuff. And so, again, this is where I'd leave it. Again, not every solution, just hopefully one good solution, right? And I feel like this is pretty good, right? We brought in our factorial code. We figured out our lengths. Again, the fact that we aren't actually using the contents of stops, they could have just went like 1, 2, 3, 4, right? And it would have been the same thing. But we get all that done. And then, of course, we did some really good searching to figure out the math, the formula that we use. And then we translate that formula into code, right? And that's how all this works, right? For the math stuff, I absolutely Google. I Google a lot to figure out the formulas, translating them into code, making it all work. Let me know what you think about that, though. Did you like it? Did you hate it? Did you go a different way? I want to see all that in my comments. Otherwise, today this has been Itinerary Arrangements, and I will see you tomorrow.